Hey guys, let's go ahead and get started on Chapter 2. Chapter 2 covers the idea of matter. We're going to talk about what matter is, also the properties of matter, and what happens when matter changes. Now, matter is divided into two categories, mixtures and pure substances. Now, we have two different types of mixtures. The first type of mixture we're going to talk about is a heterogeneous mixture. Heterogeneous mixtures are different throughout. That means that you can see the different parts of the mixture. An example would be vegetable soup or a salad. You can go and pick out the different parts of vegetable soup or a salad. That means it's a heterogeneous mixture because you can actually see the different parts that make it up. The second type of mixture is homogeneous mixture. Now, a homogeneous mixture is the same throughout. That means you cannot see the different parts that make up a homogeneous mixture because the mixture looks completely the same all the way through. An example of this would be gasoline. Gasoline looks like it's just one liquid, but it's actually made up of 15 to 20 liquids. And so gasoline is an example of a homogeneous mixture. Now let's move over to pure substances. Pure substances, you have two categories that make up pure substances. The first one is an element. Now an element is one type of atom only. When you look at the periodic table, either in your book since you're at home or on the wall when you're at school, each one of those little boxes represent one element. And that one element has one type of atom. If I'm looking at an oxygen element, that means it's only made up of oxygen atoms. And so an element is a pure substance. And so an element is only one type of atom. The second type of pure substance is a compound. Now a compound is more than one element put together. So when you put hydrogen and oxygen together to make water, that would be a compound. When you put sodium and chlorine together to make sodium chloride, that would be a compound. And so this is how matter is categorized. And make sure you know how to replicate or duplicate this graphic organizer so that you can remember that matter is made up of mixtures and pure substances, and then you can also tell what mixtures are and what pure substances are. Now, we need to talk about some vocabulary that go along with mixtures. The first one is the word miscible. Miscible means that substances can be mixed. So, example, the liquids in gasoline, how they can all be mixed together and it looks like one substance, but it's actually a homogeneous mixture. That would mean those liquids are miscible. Immiscible is just the opposite. This means that a substance cannot be mixed. This would be an example of that would be oil and water. If you've ever made brownies at home, brownie mixes usually always call for oil and water. And if you put them in the same measuring cup, you're going to see the difference. And there's actually a line that breaks up the oil and water because they're immiscible. They can't be mixed together unless temporarily, but they're always going to settle back out. Now, one thing to know, and this is kind of weird because we don't really think about this a whole lot, but gases can be mixed with liquids. So gases and liquids are miscible. And an example of that are the soft drinks that have carbonation. When you pop the top of a soft drink and you hear that fizz, that's the gas being released because it's been actually mixed in the liquid. Now, let's talk about properties of matter. We've talked about what matter is. So let's talk about properties of matter. The first type of property we're going to talk about are physical properties. Now, physical properties are any characteristic of a material that you can observe or attempt to observe without changing the identity of the substance. So the substance never changes in regards to physical properties. And some examples of this: shape, color, state of matter. Shape, if I gain or lose weight, I'm still Angela Swilly. I still have the same personality. It doesn't change who I am. So shape can change, just like Play-Doh can change shape, so it doesn't change the fact that it's Play-Doh. Color, if we paint the walls in your house a different color, you don't change the substance of those walls. You've just changed the outward appearance of them and their color. So that doesn't change the substance. It's a physical property. State of matter. When we talk about state of matter, we're talking about solids, liquids, and gases. When you take a solid piece of ice and you melt it to water, that is a physical property because it's still water. This is the most confusing one. Most of you will get confused on this one on the test. So make sure you make a note. The state of matter is solids, liquids, and gases. And whenever you go between a solid liquid, and a gas, or vice versa, those are physical properties. That's not, being a solid, liquid, or gas is not a chemical property. It's a physical property. Some other examples: length, width, volume. If you change the length of a pencil by cutting it in half or breaking it in half, it's still a pencil. It doesn't change what it is. Density and temperature. Now, density we're fixing to talk about more in depth. Temperature, the temperature of something, our bodies can be hotter or cooler. You know, when you run a fever, you're not changing who you are. You're just running a fever. And so your temperature doesn't change the identity of the substance, therefore it's a physical property. Now let's go ahead and talk a little bit more about density. Density is a physical property. You need to make sure that you know these. On the test, you're going to be asked, you're going to be given an example, for instance, density, and be asked, is this a physical property or is it a chemical property? And you need to remember that it's a physical property. Density is a physical property. Density is the mass of something per unit volume. It's the mass of something per unit volume. Density of a substance will determine if that substance will sink or if it will float. So that's how we know if something's going to sink in a pool or the ocean or float in the pool or an ocean. If something is less dense than water, it will float. If something is more dense than water, it will sink. So a brick is more dense than water, so it sinks when it's in a pool. The float that you blow up with either a pump or sometimes you have to use your own breath, right? And almost pass out doing it. But those floats that you use in the water, those float on top of the water because they are less dense than water. A ping pong ball is less dense than water. It's going to float on the top of water. Okay? Now, how do you find density? You take the mass of an object and divide it by the volume of that object, and that gives you the density. If you have a solid object, you're going to have grams. Now, mass is measured in grams, and sometimes you can have kilograms, centigrams, all that, but the main unit that we're going to focus on for calculating density is grams. It's going to be grams divided by centimeters cubed, because the volume of a solid object, if you think about a book, to get the volume of that book, remember you have to do length times width times height, and so that would be centimeters times centimeters times centimeters. So for a solid object, you're going to have grams divided by centimeters cubed. Those are going to be your units. If you have a liquid object, you're going to have, your units are going to be grams still, because it doesn't matter if it's liquid or solid, you're always going to have grams for mass, but your unit of volume is going to be milliliters for a liquid. It's just like if I have a 2 liter of Mountain Dew, that Mountain Dew is liquid, and that's why we measure it in liters. And so, but our unit here for density is going to be milliliters. Now, let's look at this again. The M stands for mass, the V stands for volume. Make sure you're getting used to these abbreviations. Make sure you know these units also. If I ask you what we measure mass in, you need to be able to tell me grams or kilograms or centigrams, something like that. If I ask you what we measure a solid's volume in, you need to be able to tell me centimeters cubed. So make sure you're getting familiar with those. It may even be a good idea to make note cards of these units, because we're going to be adding these consistently throughout the semester, and I don't want you to get bogged down to knowing what unit is what. Now, so the units are going to be G over cm cubed or G over M capital L, and those are the abbreviations for grams and centimeters cubed and milliliters. If you've never heard of the circle or the triangle method of calculating, I want us to talk about it now. And real quick, before we go to circle, I did forget to mention 1 milliliter is equal to 1 centimeters cubed. That's why we can change those units back and forth, and it can be used interchangeably for this formula. Now, this circle is what I like to use when we're doing calculations with problems, because the formula that we give you on here starts with density, and it shows you how to find density. But what if they ask you how to find mass or volume? Then you have to rearrange the equation. That can get difficult. So I like to introduce the circle. Now for the circle, you look at this part of the formula first. Right here, this M slash V, M over V. Okay, it's M divided by V. They are over one another in the formula, so that means they have to be over one another in the circle. So you place them in the circle this way. And then whichever place is left is where you put the third letter or variable. Okay, so we have our circle filled in. Now, let's go ahead and talk about this and do one example up here. I want you to write down somewhere what I require for mathematical calculations, because there are several people that just want to do it in their head, and that's fine, but it causes a lot of mistakes and simple errors that could be avoided if we just make sure we do these steps. So the very first thing you're going to do on a math problem for me, and write these down in your notes, is you're going to write out the variables, okay? And when I say variables, that means the letters in the formula. So you would write out D equals, M equals, V equals. And then you're going to fill in what you know and what you don't know. And we'll do these in a second with a formula, with an example. So step number 2, you're going to write the variables, and then you're going to write your formula in letters. Because the formula may change depending on what you're looking at or looking for. Now the third step, you're going to write your formula in numbers. So write your formula in numbers. And then your last step is going to be solve with units. And when I say with units, we talked about this the other day, that when you have a number, you have to have a unit behind it, so don't leave just the number. So make sure you've got these. Write the variables as step 1, write your formula letters, write your formula numbers, solve with your units. You have to have all 4 steps to get credit for homework or for classwork that we do. Now, this is an example. If we know that 10 centimeters cubed of ice has a mass of 9.17 grams, what is the density of the ice? And remember, you take mass, you divide it by volume, and figure out the density of the ice. I want you to go ahead and pause the tape, try this on your own, and then we'll do it all together. Okay, let's go ahead and write out our steps here on this page. So our step number 1 is to write out the variables. And so we're going to have, we know we're doing density, so we're going to have D equals, and then we're going to have M equals, and we're going to have V equals, okay? Now, what does it ask us to find? It asks us to find the density, so I'm actually going to come over here and put a question mark, because we don't know what that is. But it does give us the mass. It says the mass is 9.17 grams. And it tells us the volume, and it says it's 10 centimeters cubed. Now, the second step that I mentioned earlier is that we write the formula in letters. So that means whatever the question mark is, that's what I'm going to start out with. So whatever my question mark is, I'll start out. So D equals, and it's going to be M over V. So M over V. Now we're going to do our third step, and we're going to write our formula in numbers. So we're going to have D equals, because we don't know what it is, equals 9.17 grams over 10 centimeters cubed. Now immediately, if they had not told you this was ice, you could tell it was a solid because of the centimeters cubed. Now step number 4 is solve. So we go ahead and solve the 9.17 10 centimeters cubed, or divided by 10 centimeters cubed, and that's going to give us 0.917 grams per centimeters cubed. Remember, it was G over centimeters cubed in our problem, so that's going to be our units that we end with. You keep them the same right here. So G over centimeters cubed are actually your units, and we say that as grams per centimeters cubed. Now, let's pretend that you actually were asked to locate mass. And what I'm going to do is I'm going to go back just a minute so we can look at our circle. If you were asked to locate mass, what you would do is you would cover mass up with your finger, and it gives you the formula. It tells you that D and V are going to be in your formula. When they're next to each other in the circle, that means you've got to multiply them together. So that means you would take the density of the substance, the volume of the substance, and multiply them together to get the mass. If they asked you to find volume, you'd come down here and you'd come down to volume and you'd cross it out or put your finger over it, and you would know to calculate volume, you do mass divided by density. We'll talk about this more in depth and do some practice when we get to class tomorrow, but I just wanted to make sure I go ahead and talk about that circle more in depth. So your answer was 0.917 grams per centimeters cubed. Now that finishes the physical properties of matter, and now we need to go ahead and talk about the chemical properties of matter. A chemical property describes how a substance changes into a new substance. Now this can be either by combining with other elements, or it could be by breaking apart into new substance. So it could be combining or breaking apart. Either way, if something is changing, if the identity of something is changing, that means it's becoming a new substance, and that's a chemical property. Examples are going to be flammability and reactivity. And I want to add a third one in that you need to add into your notes. A third one, and the reason why I don't have it on here is because it's actually reactivity, but some of us don't know that it's reactivity. So I want to make sure that we know that rusting, that is the air reacting with metal, and so it's reactivity, and so it's a chemical property. So make sure that you know that rusting or rust is a chemical property. Now, flammability is something when it burns. Reactivity is when something reacts with each other. So those are two things reacting with one another to form a larger substance like we talked about, or it could be a reaction that causes things to break apart into new substances. Now, let's look very quickly, and before we look at changes of matter, I want you to pause the tape, and I want you to write a summary. And this is what I'd like you to do. I want you to put a timer on for 2 minutes. This is called a speed dating summary. And I want you to write everything that you possibly can on page 2 of your notes about what you've learned so far in this video. So in the 2 minutes, write everything that you possibly can write in those 2 minutes, and then restart the tape once you're ready. All right, let's go ahead and talk about changes of matter, and this is going to finish up chapter 2 for us. Now, a physical change. Physical changes have to do with the physical properties. This is a change in size, shape, or state of matter, like we talked about ice going to liquid or liquid water going to water vapor. Those are all physical changes because the identity of the substance does not change. So that means it's just a physical change, and it has to do with the physical properties. Some examples are melting ice, tearing a piece of paper, cutting your hair. Another one would be painting the walls, painting cabinets, changing. What if I wanted a cabinet to be shorter? I could saw off the top and make it a shorter cabinet. That is all physical change. Now what about chemical change? Chemical change is when you change one substance to another substance. You cannot distinguish one substance from another. That means what you end up with, that's what you have, and you can't get the original back. That's an easy way to look at it. Physical changes, a lot of times I can get the original form back. Not always, but a lot of times I can. Like if I paint a wall red, but I really want it back to the original taupe, I can go back and change it. But a chemical change, you can't get the original substance back. Some examples. When you have sodium mixing with chlorine to form sodium chloride, and that makes salt. And you started with sodium, you started with chlorine, and then you ended up with salt. That's a whole new substance. Hydrogen and oxygen forming water. That is an example of a chemical change. When you look at a glass of water, you're not seeing the hydrogen. You can't pull the hydrogen back out of it. It's a chemical change, and therefore you can't get the original substance back. Now, metal rusting, like we talked about earlier, is another example of chemical change. Okay, metal rusting is chemical change. That's when the air is reacting with the metal. Now, all you have to do is a short summary here. I want you to write a Facebook status summary. That means if you were to write a Facebook status about physical chemical changes, what would you put? And go ahead and write that on your paper, and I'll see you in class.